All right, let's just get right into it. There is a pretty hard truth about the AI industry right now. Most data scientists can train a machine learning model. They can clean the data, tune the hyperparameters, and get fantastic accuracy right there on their local machines. But only a very, very small percentage of them actually know how to take that model and deploy it into a real, live production system. And honestly, that is exactly what we are mastering in today's Explainer. We're going to take your skills from that isolated notebook environment straight into the real world.
I absolutely love starting with this quote from a senior data scientist because it serves as a massive pattern interrupt. Training a model is only 20% of ML work. Making it reliable in production is the real challenge. There's this huge misconception out there for beginners who think the job is completely done the second the model hits 95% accuracy. But as someone who's been around this space for a while, I can tell you for sure that deployment skills are the true differentiator. It is literally the difference between running a cute science experiment and building an actual product.
So here is our roadmap for this explainer. First, 1. The deployment reality check. Then 2. Notebook versus production systems. Next up, 3. The ML deployment architecture. Then we get to 4. Building a prediction API. And we'll wrap things up with 5. Real-world machine learning.
Okay, let's kick things off with Section 1, the deployment reality check.
Let's be real for a second. A brilliant predictive model that's just trapped on your laptop? It provides absolutely zero business value. Zero. This right here is the 80-20 rule of a machine learning engineer's reality. Only 20% of the job is the actual model training. That overwhelming 80%, that's production, reliability, and scaling. In fact, tech giants often have 10 times more engineers just maintaining the infrastructure around a model than they do data scientists tweaking the actual algorithm. If you want to accelerate your career, you've got to live in that 80% zone. Businesses don't just pay for accurate algorithms, they pay for algorithms that can securely and reliably serve thousands of customers the exact millisecond they click a button on a website.
Moving right along to Section 2, Notebook versus Production Systems.
We really need to contrast the cozy environment where a model is born with the pretty demanding arena where it actually lives. These are two entirely different worlds. On one side, you have the notebook model. You know this Jupyter environment well. It's super experimental, it relies on manual execution, and well, you're the only one using it. But on the flip side, the production model. This lives inside an API. It interacts with totally unpredictable users, and it demands constant, 24/7 monitoring. Think about it. If your app goes viral overnight, a production model scales seamlessly to meet that demand. A notebook? Yeah, it just crashes.
All right, let's get into the mechanics in Section 3, the ML deployment architecture.
Let's unpack the blueprint of how a machine learning system actually talks to the outside world. It's a really beautiful, logical flow for a single prediction request. Step 1, the user interacts with your product. Maybe they're hitting submit on a loan application. Step 2, that click goes to a front-end application, like their web browser or a mobile app. Step 3, that front end sends the data over the internet to a FastAPI backend. FastAPI is just a modern, super high-performance web framework for Python. Step 4, that backend takes the incoming data and feeds it straight into your trained machine learning model. And finally, Step 5, the model spits out an answer which gets packaged as a prediction response and is sent all the way back up the chain to the user. The whole thing happens in milliseconds, but that is the complete lifecycle.
Now, to make that whole architecture actually work, we have to talk about model serialization. I want you to think of this as basically freezing your trained model. When you train a model in Python, it exists in your computer's active memory, the RAM. If you turn off your computer, poof, it's gone. Serialization, using popular Python libraries like Pickle or Joblib, converts that active, thinking brain into a storable file format. You freeze it, you safely transport it over to your production server, and then you thaw it out inside your API so it's ready to start making predictions.
But serialization is really just the brain of the operation. To give it a body, you need a few more things. You need API endpoints. Think of these as specific digital doors your front end can knock on. You need strict request and response formats, so the front end and back end don't misunderstand each other. You also definitely need model versioning so you can safely swap in a newer, smarter model next month without breaking anything. And of course, system monitoring to make sure the whole operation hasn't just flatlined while you were sleeping. Okay, time to get our hands dirty. Section 4, Building a Prediction API.
We are going to build a real-world customer churn API together. Here's our exact implementation roadmap. Step 1, train the model. Step 2, save the model. Step 3, create the FastAPI API. Step 4, load the model back up.
Step 5, send a prediction request. And Step 6, receive the prediction. Let's actually look at the Python code for this. All right, steps 1 and 2. Now you're probably super familiar with model.fit. That is the classic data science part where the model learns all the churn patterns from the data. But the real engineering magic, that happens on the second line, joblib.dump. We are taking that fully trained model and saving it directly to our hard drive as a pickle file. Just like that. It is serialized, frozen, and completely portable. Next up, we jump over to our server code to build the actual API. First, we initialize the framework with app equals FastAPI. Easy enough. Then, we create an endpoint using a Python decorator, app.post, passing in the route /predict_churn. This code right here is essentially hanging up a glowing digital open sign on a very specific door. It's telling our server, hey, listen for incoming data at this exact web address. And by the way, expect it to be a request about customer churn.
So what happens when someone finally knocks on that door? The API wakes up and runs its internal logic. Let's break down the first line of execution. Loaded_model equals joblib.load churnmodel.pkl. We are taking that frozen file we saved earlier and thawing it out right into active memory on the server. Then we take the incoming, brand new customer data payload and feed it directly into the loadedModel.predict function.
And finally, we've got to send an answer back. Remember, front-end applications like a web browser, they have no idea what a complex machine learning object is. They only understand really simple data formats like JSON. So we take the raw prediction, format it into a nice, clean Python dictionary, and return it. We are literally just telling the front end, hey, the churn risk is this specific integer, and the status of your request was a success. It's simple, it's clean, and it's totally industry standard.
Which brings us to our final section, Section 5, Real-World Machine Learning.
We've written the code, so let's zoom out for a second and see how massive companies are leveraging these exact same architectural principles today. Whether it's a huge bank running fraud detection through a high-speed API to block a bad credit card swipe in milliseconds, or a massive streaming giant using a scalable backend to serve you personalized movie recommendations, the core concept's identical. Even the customer churn API we just walked through, that's used by huge enterprises to instantly trigger retention offers and literally save millions of dollars. The FastAPI and Joblib architecture we just explored is the foundational building block for all of it.
And that brings us to our final thought. Today, we successfully made the jump from isolated data science thinking to scalable, industry-ready machine learning engineer thinking. We explored the 80-20 rule of production, we mapped out the architecture of APIs, and we even walked line by line through the actual deployment code. So the question I want to leave you with today is this. Are you ready to finally take your models out of the notebook and put them into production where they can actually change the world? Thanks for joining me on this explainer, and I'll catch you in the next one.